Hello, I'm Chris Athanas. I'm a KMP developer. Update on the portal, back there, I think, is that the AI model that they're training to for the tool, they run out of AWS credits, so they got to figure that out. And they said they would probably have it done by Tuesday. So we're hoping that it gets fixed and we can close that portal, which is the pain of my existence. Okay, so today we're going to be going over. I'm just doing like an addition to the universal architecture pattern. Your universal architecture. What did I call it? The universal application architecture. Right. It's just people basically. Okay. It's just way of figuring out what these people are talking about in these videos, like in Byte Byte Go, and I'm gonna do a translation to human terms. Okay, here we go. Give him a like and subscribe over there. He does great work. All the animations are does help,
Soft-
even though he gets some details wrong. So I'm gonna go into those details. Okay, shut up, Chris. Shut up.
Software architecture is to applications what foundations are to buildings. Build it wrong, and no matter how beautiful it looks, it will crumble. In today's discussion, we'll unpack some prevalent software architecture patterns that form the backbone of countless applications and platforms we interact with daily. Over the next few minutes, we'll explore 5 key patterns that have shaped the industry. Let's start with layered architecture. This pattern separates the components of a system into distinct layers, typically the presentation layer, business logic layer, and data access layer. For instance, in user interface design, we often see the model view presenter pattern. It's a specialized form of layer architecture. Here, the model represents data and business logic. The view displays this data, and the presenter serves as a bridge to ensure a clean separation of concerns. The primary goal of layered architectures is to promote separation so changes in one layer don't negatively impact others.
Okay, so kind of the idea here, he's got the presentation, business, persistence, database layer. Just think of it like it as if it was an office full of people. How would you separate these things out? So, in human speak, this would be the receptionist or the sales floor. If it was an office or a building, if this is like a say it's a let's say we're talking about a company that sells cars. All right, so they got the sales floor here, receptionist, and the business has got the sales desk. Like somebody wants to come in and buy a car, they're going to go over to the sales desk. They might also have a service desk. That's the business logic layer, right? Then you have the persistence layer, which is could be a secretary who takes all the paperwork from these different individual places here and puts it into the database layer, which is the filing cabinets. Okay, so that's a more humanized view of what is actually happening here. And when you talk in these terms, if you can put it in these terms for people, your stakeholders, this will help them design the system so it works properly, and gets all the corner cases. Okay, let's keep going.
This structure provides abstraction and encapsulation, with each layer having a distinct responsibility. Next is event-driven architecture. This pattern promotes the production and consumption of events between loosely coupled software components and services. Components broadcast events when something notable happens, and other components subscribe to specific events they are interested in. This allows for highly decoupled architectures. One prominent example in this domain is CQRS. With CQRS, the data write operations, commands, are separated from read operations, queries, and changes are often communicated through events. This makes the system inherently event-driven. The pub/sub model, where components publish and subscribe to events, is commonly used in such architectures. Here, components don't call each other directly. They merely react to published events.
Right. So here's the English translation of that, of the human translation. So you have an event producer. Someone comes in and wants to buy a car, or they phone in. This is on this example. We're saying this is calls in by the phone, and the event ingestion, or the message broker, is the receptionist who is also running by buying a phone, which would be the message broker, right? The phone. So there's events to be produced. The message broker would be this receptionist person, and she just calls up or sends an email or sends a inter-office memo, whatever, to the producers. In this case, would probably be the phone, right? To the sales, service, and parts. Because it meant consumers for sales, service, and parts. All right, so that's what they're talking about. There we go.
Moving on to microkernel architecture. This pattern emphasizes separating core system functionalities into a small microkernel and extend the functionality into add-ons or plugins. In operating systems, for example, a microkernel might oversee vital tasks like inter-process communication while offloading other system functions to external components. An application example is the Eclipse IDE. Its core runtime handles the plugin architecture, and features from Java tools to Git integration are delivered as plugins. This design prioritizes extensibility, ease of maintenance, and fault isolation.
Right, except he got the arrow is the wrong way here. That's fine. Whatever. is details. So this is the so Git is a plugin to Eclipse. So Java is a plugin to Eclipse. So here it is in English. So a plugin here. So this would be like someone who had a business that did a lot of uses a lot of contract services for everything. They have contractors for everything. So they have a plugin contractor, right? Who this office will run with we have sales organization number one, sales organization number two. We swap them in and out as long as we have the protocols that we all talk to each other by. As long as we have a common language. I can use a different reception company. If that reception company's on vacation, we can use an answering service. It's that kind of thing. So as an office using independent, swappable contractors, that's the kind of the humanistic idea. There we go. There we go. Let's go to the next one.
Whether it's an OS component or an Eclipse plugin that encounters an issue, the core system remains stable and unaffected. Then we have microservices architecture. This decomposes an application into a collection of small, loosely coupled services. Each service implements specific business capabilities, contains its own data model, and communicates via APIs. Netflix, for instance, uses microservices to handle everything from movie recommendations to billing. This architecture promotes modularization of functionality, so services can be developed, deployed, and scaled independently. It increases agility and allows companies like Netflix to rapidly innovate. The trade-off, however, is the added complexity in managing inter-service communication and maintaining data consistency.
Right.
Last but not least,
So let me go back here. Go back. Ooh. Okay, so here's the English in plain English. It's basically so it has the client here, which is the customer, and they're calling in, which is the API gateway, which is the main switchboard. Hello, how may I direct your call? And then if you want to buy a new car, so it goes over to the sales office, service A, sales office. Oh, I have a problem with my billing. I can't make my payment this week. Okay, or this month. Okay, that's accounting office. Oh, this goes. Oh, I need to get into a part. There's something's wrong with my car. I can't. The brakes don't work or something. And they go. You have to go to the service office. And each office has its own database. Sales has the sales files, accounting has the accounting files, and the service has the service files. And they don't blend with each other unless this accounting office needs to call over to the sales office, and they'll call over to see what the sales are, or go over the service and see if they got did they place the order or not, blah blah, that kind of stuff. So that's the idea of the microservices. That's the big idea.
Last but not least, we have monolithic architecture. At its core, a monolithic design sees all components of an application, from data, access, and business logic to the user interface, bundled together into a single codebase and run as a single unit. This approach simplifies development and deployment, making it a go-to for many startups and smaller applications. However, it's worth noting the rise of the modular monolith. This approach retains the benefits of a single deployable unit, but emphasizes clear modular boundaries within the codebase.
Okay, so I want to talk about this one first. This one here. This, what do you call it? This just the regular monolith.
Worth noting the rise of the modular
Okay, so it's not that one. It's dang it.
go-to for many startups and smaller applications.
Just show the picture here.
However, it's worth noting the rise of the modular monolith. This approach retains the benefits of a single deployable unit, but emphasizes clear modular boundaries within the codebase. This allows for easier maintenance and scalability. It's a middle ground which offers the simplicity of a monolith while paving the way for potential future transitions.
Okay, so what he's talking about here is basically having a little simple office that you have it's like a little a one room office or two room office, and it's like one place. It's a small family owned business, and they have sales and reception and parts and accounting and inventory. It's all in one place. There's not even a phone. There's like not even phone lines. It's just we talk to each other, and we all use the same filing cabinet. So that's really that's what this is about. So there's the front office, sales, receptions. You come into the front door. I've been into insurance offices or stuff like this. They have a front door reception and the sales and the reception and the parts and everything. Like if it was a little small motor dealership, mom and pop motor dealership. So all departments for all services are within a single office. And if the office closes, all the departments are closed. You can't just have the service department open and the sales. When this office closes down, everything closes. So that's kind of the whole idea with the monolithic. And he said you could split these up to like, okay, we have so George is at the sales desk. It's not just George handling sales. We're going to call it the sales desk now because we're about to expand, maybe to increase operations into other parts of town or another state or something like that. that's what allows them to give these labels that have Jim over. He does the accounting. No, it's now the accounting department. It's not just Jim or Joan over in the inventories. Does she know where the parts are? And that's not she's not just Joan going to figure out where the parts are at. They call it the inventory department. So what he's talking about here, he's splitting these things up into separate boundaries so we can then expand it later and replicate this system so we can have a efficiencies of scale. So that's what he's talking about.
to architectures like microservices. Regardless of the approach, many successful platforms start with a monolithic or a modular monolithic structure before considering more distributed architectures. And there you have it, a quick tour of 5 foundational software architecture patterns. The right choice always depends on our specific challenges, requirements, and contexts. So which patterns resonates with you? Drop a
So yeah, so you can see that the ideas are repeated over and over again. I'm gonna leave a link to the diddly do. I'm in Mexico right now. They're having a fiesta out there. That's all that fireworks is at. So I'll leave this link to this Excalidraw document. And yeah, this is pretty useful little mapper for your stakeholders. All right, that's about it for now. Talk to you soon. Give me a like and subscribe.